TensorFlow is one of the leading frameworks for implementing deep learning algorithms. When I'm building projects, TensorFlow is actually the tool that I use the most often. And the other popular tool is PyTorch. But we're going to focus in this specialization on TensorFlow. In this video, let's take a look at how you can implement inference in code using TensorFlow. Let's dive in. One of the remarkable things about neural networks is the same algorithm can be applied to so many different applications. So in order, both for this video and in some of the labs, for you to see what a neural network is doing, I'm going to use another example to illustrate inference. So sometimes I do like to roast coffee beans myself at home. My favorite is actually Colombian coffee beans. So can a learning algorithm help optimize the quality of the beans you get from a roasting process like this? When you're roasting coffee, two parameters you get to control are the temperature at which you're heating up the raw coffee beans to turn them into nicely roasted coffee beans, as well as the duration or how long you're going to roast the beans. And in this slightly simplified example, we've created a data set of different temperatures and different durations, as well as labels showing whether the coffee you roasted is good tasting coffee, where cross here, the positive class, y equals 1, corresponds to good coffee, and O, the negative class, corresponds to bad coffee. So it looks like a reasonable way to think of this data set is if you cook it at too low a temperature, it doesn't get roasted and it ends up undercooked. If you cook it not for long enough, the duration is too short. It's also not a nicely roasted set of beans. And finally, if you were to cook it either for too long or for too high a temperature, then you end up with overcooked beans. They're a little bit burnt beans. And so that's not good coffee either. And there's only points within this little triangle here that corresponds to good coffee. This example is simplified a bit from actual coffee roasting, even though this example is a simplified one for the purpose of illustration. There have actually been serious projects using machine learning to optimize coffee roasting as well. So the task is, given a feature vector x with both temperature and duration, say 200 degrees Celsius for 17 minutes, how can we do inference in a neural network to get it to tell us whether or not this temperature and duration setting will result in good coffee or not? It looks like this. We're going to set x to be an array of two numbers, the input features, 200 degrees Celsius and 17 minutes. Then you create layer 1 as this first hidden layer of the neural network as dense, open parenthesis units 3, that means 3 units or 3 hidden units in this layer, using as the activation function, the sigmoid function. And dense is another name for the layers of a neural network that we've learned about so far. And as you learn more about neural networks, you learn about other types of layers as well. But for now, we'll just use the dense layer, which is the layer type you've learned about in the last few videos for all of our examples. So next, you compute A1 by taking layer 1, which is actually a function, and applying this function layer 1 to the values of x. So that's how you get A1, which is going to be a list of 3 numbers because layer 1 had 3 units. And so A1 here may, just for the sake of illustration, be 0.2, 0.7, 0.3. Next, for the second hidden layer, layer 2 would be dense of, now this time it has 1 unit, and again, the sigmoid activation function. And you can then compute A2 by applying this layer 2 function to the activation values from layer 1 to A1, and that will give you the value of A2, which for the sake of illustration is maybe 0.8. Finally, if you wish to threshold this at 0.5, then you can just test if A2 is greater than or equal to 0.5 and set y hat equals to 1 or 0, positive or negative class accordingly. So that's how you do inference in the neural network using TensorFlow. There are some additional details that I didn't go over here, such as how to load the TensorFlow library, and how to also load the parameters W and B of the neural network. But we'll go over that in the lab, so please be sure to take a look at the lab. But these are the key steps for forward propagation and how you compute A1 and A2 and optionally threshold A2. Let's look at one more example, and we're going to go back to the handwritten digit classification problem. So in this example, X is a list of the pixel intensity values. So X is equal to a NumPy array of this list of pixel intensity values. And then to initialize and carry out one step of forward propagation, layer 1 is a dense layer with 25 units and the sigmoid activation function. And you then compute A1 equals the layer 1 function applied to X. To build and carry out inference through the second layer, similarly, you set up layer 2 as follows, and then compute A2 as layer 2 applied to A1. And then finally, layer 3 is the third and final dense layer. And then finally, you can optionally threshold A3 to come up with a binary prediction for Y hat. So that's the syntax for carrying out inference in TensorFlow. One thing I briefly alluded to is the structure of the NumPy arrays. TensorFlow treats data in a certain way that is important to get right. So in the next video, let's take a look at how TensorFlow handles data.